Hello dear student, this is Dr. Vijaya Babu. So we are continuing the lecture series of networks. So in the last video, I think we have done with the problems of case 2 where there is a combination of dependent and independent sources. Okay, so now we are going ahead with the third case. So this is a problem which is given in the third case, that is I can say this is the case where the current source is connected in between the two meshes. Okay, if you clearly understand here, there is a 3 ampere source. So this 3 ampere source, this is connected in between the two meshes. Okay, in this case it is not possible to follow the KVL approach. That means you cannot apply the KVL across this current source because you don't know the voltage drop across this current source. Okay, mesh analysis always is nothing but KVLs. Even you try to apply KVL in this loop, so it is not possible because you don't know the voltage drop across the 3 amperes. Similarly, it is not possible to apply KVL in the this loop also. Okay, it is not possible to apply KVL. However, so here KVL is not possible, here KVL is not possible, but however you can apply KVL in this loop, no issues. Okay, so for such type of problems, okay, so how can we go ahead? Usually we'll try to apply the concept of what you call it as super mesh for this approach, for this type of problems. So applying the super mesh, once again redrawing the circuit, see here. So this is 6 volts, 2 ohms, and you have a current source here, 3 amperes, and it is 4 ohms, it is 2 ohms, it is 8 ohms. Okay, so now as usual we'll try to go ahead with the standard procedure, that is considering the mesh currents I1, I2, I3. All of them I am taking them as what? Clockwise mesh currents. Okay, now I'll try to apply KVL in the first loop. However, KVL in the first loop it fails, it is not possible to apply. I have to apply KVL in the second loop. In the second loop it's okay, you can apply the KVL. So KVL in loop 2. Okay, so KVL in loop 2. So I start here, I walk like this. Okay, I am at the 2 ohms. The drop across the 2 ohms is affected by two adjacent currents, that is I1 left side, I2 right side. But however, when you are walking, there is I2 is with you, I1 is opposite to you. So I1 is your enemy now. Okay, but I2 is your friend. Okay, then you have crossed the resistor, then you are here, you are here, then you are here. Okay, then you are at the 2 ohm resistor here. So plus 2 times, only the drop is affected by current I2. So this is I2 is with you now. It is with you means it is your friend. So plus I2. Then you cross this 2 ohm. Okay. Then you are here. Then you are here. Then there is a 4 ohms. So 4. Then here I2 is your friend, but I3 is coming opposite to you. So that is why it is your enemy. Okay. So is equal to once again 0. Okay, so from this minus rearranging the terms, 2I1, I2 means 4 plus 2 6, 6 plus 2 8, 8 I2, and then minus 4 I3 equal to 0. Take it as equation 1. So you have only one equation but 3 unknowns here. So how to solve such type of problem? So in that case you can apply you can represent the current source in terms of current source value in terms of loop currents. Okay, that means you have a 3 amperes going downwards, but if you want to represent this current in terms of loop currents, I1 is coming down, I3 is going up. Okay, I1 is coming down and I3 is going up. So from this context, simply I can represent 3 amperes in terms of I1 and I3 as So now I1 minus I3 is equal to 3 amperes. This is equation 2. So whenever there is a current source, it is not possible to apply KVL on either sides. Okay, but you can represent that current source value in terms of the loop currents. That was I1 minus I3 is equal to 3. This is the second equation. Even though it is not possible to calculate I1, I2, I3 because there are two equations, three unknowns. Okay, so in such case, so we can go for the super mesh concept. Okay, so here number of variables are greater than number of equations. So apply super mesh concept. So in applying the super mesh concept, how you can consider the super mesh is, see here, usually till now you have walked only along the individual loops. Okay, now we'll try to walk along a bigger outer loop. See here, always KVL satisfies in any closed loop. Okay, so that is why I start walking from here. I start walk like this. So I will try to apply KVL in this loop now. This is the super mesh what I have considered to apply KVL. So I am here. So you are touching minus of 6 volts. So minus 6. Okay. Then you have crossed the battery. Crossed here. So you are here. So you are here. So you are here. Now you are here at 2 ohms. So plus 2. Check the currents, loop currents. Only I2 is important. So I2 is with you. Okay. Then you have crossed this one. You have crossed here. Okay. So now you are at the 8 ohms. At 8 ohms, I3 is also your friend because it is also with you. It is in your direction. So you crossed 8 ohms. So there is no drop here. It is an equipotential body. Finally, you come back to the original position is equal to 0. So this is a very important equation because I have not applied the KVL on the individual loops as in the case of case 1 and case 2. Here I have applied the KVL in a bigger outer loop, okay, where there is no current source. Okay, so this concept we call it as super mesh. So in this way you will be getting the third equation. So rearranging the terms, 2I2 plus 8I3 is equal to 6. This is equation 3. So number of equations now is equal to number of unknowns. Then immediately solve for, you can solve for I1, I2, I3. Okay, dear students. So in this way you can apply mesh analysis whenever there is a current source connected or exists between the two meshes. However, we cannot write the KVL in the two meshes. It is not possible. But you can take the advantage of the super mesh concept and you can apply the KVL in the outer loop. Okay, and then you can go ahead. Lastly, I want to add one more interesting thing here. So I will try to use the violet color now. So is there any another approach without taking the outer loop? Is there any another loop possible? Means, see here, the students, I am drawing it. You can start here. Okay, so you can go like this. You can go like this, and then you can come like this also. Okay, and this way downwards you cannot go because there is a current source. So take right. You can go like this. You can go like this, and finally you can reach the same initial point like this. Okay, so this loop also you can apply, and this is also the concept of super mesh. In both the cases you will be getting the same answer. Need not to be worried because the voltage drops in a closed loop is exactly equal to 0. That's what basic KVL says us. Okay, so dear students, in this way you can apply the super mesh concept for a problem something like this. Okay, so with this, I am concluding the super mesh concept. So thank you for giving this opportunity. If you really enjoy the videos of lecture series of network analysis, okay, like them and subscribe the channel. Also, you can comment it so that it will motivate us to do a lot more videos on it. So lastly, one point I would like to add is network analysis. Problems are not that much important, but the concept behind them is important. Once you understand the fundamental concepts of everything, then any type of problem can be solved. That means the methods what you are following are most important in the network analysis. So always try to concentrate on the methods that you are following, not on the problems. Okay, so once you understand those methods perfectly, then you can play with the networks. Okay, so thank you for giving this opportunity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.